students. So today we're going to be covering Module 7, which deals with standard deviation. Now, standard deviation is another way of measuring the spread away from the center. So if you remember in Module 6, we did the spread away from the median. Again, that's the kind of halfway cutoff point. And in Module 7, we're going to talk about the standard deviation. Now, the standard deviation by itself, we kind of lead in this unit. We start off with something that's a little bit different than standard deviation to help give you an idea of where it comes from. The formula for standard deviation is a little bit more complicated than this first idea, and so let's take a set of data over here to kind of get the feel for it. So here's a set of data with a mean of 16 and a median of 16, so we can kind of see the split right here down the middle. Now for the median, we already know half the data is above and half the data is below. However, when we're talking about the mean, now what we're referring to is from this point, this tipping point, which is our mean, we have an equal amount of distance from the mean above and below. And so we're going to start with the idea of an average distance from the mean. So let's take a look going to the right of the mean, and for these I'm going to use kind of green arrows. So here this first dot is one length, one distance away from the mean. So think of that as like a +1. The next is 2 units away from the mean. It's above the mean, so it would be a +2 if we were kind of measuring that. Over here there are 3 numbers, and each one of those is 3 units above the mean. So kind of now as you're thinking about that, all 3 of those count 3 above. And then there's one way at the top over here that is 4 units above the mean. Okay. So if you take a look over here, you have a 1, a 2, a 3, a 3, a 3, and a 4. Okay, so add those up, you get a total of 16. Now that's 16 in distance away from the mean. If we go the other direction, I'll use red arrows for this, then first I see 1 and 1, so each of those is 1 unit below. This one's 2 units below, 3 units below, 4 units below, and lastly 5 units below. That's the one way down here. So if I was adding all of these up, then I would have 1 plus 1 plus 2 plus 3 plus 4 plus 5. Plus 5. So let's see here. That gives me 9, 10, and 16. So what I have is the same amount of distance above and below the mean. This is why the mean is called the balancing point. It balances all of that out. So what does that also represent for us? It represents that if we erase these numbers and we move something, for example, if I move this point over 4 units, 1, 2, 3, 4, so I'm going to go to my data set, I'm going to take the number 11, and I'm going to turn it into a 15. Let's see what happens to the mean. Okay. The mean has now increased. It's no longer 16, it's now 16.3. The balancing point has gone up. Notice the median has not gone up. There's still the same amount of data above and below. I might want to shrink this dot size down just a little bit more so they can fit on the screen. There we go. Okay. But by moving 1.4 units up, I could also move another point 1, 2, 3, 4 units down, and that once again will balance everything out. So if I do move this other point 4 units down, make it a 16, what you'll see is that the mean is back to 16, and I've got this nice balance again. Now what I have done though is I have shrunk the amount of distance there is to the mean by quite a bit. I moved 4 and 4 on each. So now the distance from the mean would be 12 above and 12 below. So if we take that 12 above and 12 below and we divide it by our number of points, which in this case is 13, we would be able to calculate what's called the average distance to the mean. So we're kind of balancing that out. Standard deviation is very similar. Standard deviation, though, uses a little bit of a difference. Instead of just taking the distance whether it's above or below, we're going to go ahead and do something slightly different. So to find the distance, you can just do your data value minus the mean. But because that would be positive or negative, we do have to take the absolute value. And the reason we need the absolute value in there is because whether it's above or below, we just want the distance instead of distance and direction. So those are a couple key pieces here. For standard deviation, we do something pretty similar to this. So again, we would normally add all of these up and then divide by however many numbers we have. If we're doing standard deviation, the only difference, let me grab my other pen here. The only difference with standard deviation, oops, let me come down here and finish this one off. If I was doing the average distance to the mean, I would add all of these distances up and then divide by how many data values I had. For the standard deviation, what we do is we take the data value, we subtract the mean, and depending on whether it's a population or a sample, this might be x bar as well. So it could be x bar, just be aware of that. And what we're going to do is we're going to take that distance, kind of, and we're going to square it. Now, squaring it makes it not be negative anymore, similar to how the absolute value made it not be negative. And then we add all of those up, and we divide by the number of data points. And to finish it off, to get it back to what we started with, because if you square something, now instead of inches, we have square inches. So we need to take the square root to get it back. So as I said, this formula for standard deviation is a little bit more challenging, but we can kind of see it does calculate using the web apps. Right there, the standard deviation is 2.31. And that gives us kind of a typical distance away from the mean. You know, what is a point? How far away are we, typically? We're typically about 2.31 units away from the mean. Let's see what happens if we do a small tweak as we did before. And so what I'm going to do is I'm going to take that 16 and make it back into a 20, and take that 15 and make it back into an 11. Let's see what happens here. So notice those 2 points. I do have to shrink the dots down a little bit more to make them fit. There they go. You'll see the points here. There's a 20, and there's my 11 again. Back to a mean of 16, but now my standard deviation is higher, which again indicates that on average I'm now further away from the mean because these values out at the edges. So if you really wanted kind of a pretty boring set of data, what you could do is just take a set of data where you had basically the same number over and over and over again. And so here the number 19 is repeated 9 different times. Guess what? The mean is 19. The standard deviation, I don't think we'll be able to fit all these on the screen. Here, histogram maybe would be better if I refresh. It's all 19s. But if you take a look, what's my standard deviation? My standard deviation is 0. Because how far is it on average for you to get to the mean? Well, every single data point is 19, so the standard deviation would be 0. And that's the smallest you can get. As soon as I add one more data point on here, I'll add the number 20. 20 now changes the standard deviation. Now it's very, very small, but it's still positive. And the mean has gone up a tiny bit as well. So hopefully this kind of helps you understand the idea of standard deviation when it comes to our data sets. And again, if you have something kind of crazy, if you could jump back here to kind of some of these other ones from the textbook examples, you'll notice here's a sample of 20 with a mean and a standard deviation. If I take a look at my dot plot here, the data are distributed around quite a bit. This is sodium in cereals, so I can kind of see where it's at. My mean is 167, so my mean is somewhere up in here, and that's the balancing point. So you'll notice there's a lot of data points very close to it and above, which allows for there to be kind of some that are spread out way down below to kind of balance. That's like fair trading there. Okay, so what happens if one of these outside points, maybe it was a typo, this one up here that was a 340, if I go back and I make it a 140, what do you think is going to happen to the standard deviation? Let's see. Make it a 140. I hope you said that it would go down, because we're taking something that is quite a ways away from the mean and bringing it back very close to the mean. Now let's take one of these, what is this, a 150? So 150, the mean is 157, so 150 is pretty close to the mean. If I push this 150 down to this, maybe we'll make it a 10, take a 150, I'm going to make it a 10. What do you think is going to happen to the standard deviation? And I hope you said that it would increase, and it has decreased all the way down, increase. It has increased up to 73.6. Now the reason for that is I pushed something further away from the mean. When you spread things out more, the standard deviation goes up. So those are the big ideas for this unit. If you want to check your module pieces, you're going to have 14 pieces here as well. There is a lab on drinking habits, and so that's a chance for you to once again kind of practice using R or RStudio. You're making a distribution of weekly alcohol consumption, and then trying to decide, based on the numerical measures, do you think there's a problem with drinking at this university? Again, you can use RStudio or the web apps, and it's up to you to decide what would be the best type of graph to represent this data. Next up, we're going to do relationships with categorical data, and that's going to lead us to an idea like conditional probability and two-way tables. So we're going to move away from the numerical data that we've dealt with in 5, 6, and 7. We're going to jump over to categorical data. We're going to talk about that in Module 8. All right, off you go.